Okay, hello everyone. This is our weekly API work group meeting. Welcome. Joined. Now, in terms of the agenda, we got a couple things. Just one that I will mention. It was a request to have some discussions around extension capabilities for SPDK. There is a pull request in the SPDK bridge that you guys can take a look at. This will probably be a topic that we'll cover in a later meeting. The folks who have the pull request out are unable to attend today, so we'll just shelve that and plan it for a future discussion topic. Beyond that, we want to continue delving into the Kubernetes and CNI discussions that we've been having going on. There's been at least some actions from the last time in terms of trying to dig deeper into the overall architecture, what it's going to look like, how we can map. There is the K8 thread that's going on. I know that Tashi's contributed some concepts out there. Tashi, did you want to walk through those with everybody that from what's on the thread, or open it for general discussion?
I'm fine either way.
Yeah, so why don't you kind of walk through what you had in mind, so that, and then we'll kick it off for a general discussion from that.
Sure. You're talking about the Slack channel, Slack?
Yes, I'm talking about the Slack channel discussion, okay. Right?
Let me share my screen.
Sure.
Okay, in the Slack channel, I don't know if you can, let me see if I can make it bigger. And doesn't, it doesn't look like it's making it bigger. But
you want me to try? You want me to try sharing it, Tashi?
Oh, am I sharing?
Yeah, you're sharing. You want me to try and see if I can make it larger for everybody?
Oh, okay, yeah, go ahead.
Yeah, all right. Let me do that. I will just pull up the Slack window. There we go. Hopefully this will be larger for everyone. Is that bigger?
Yeah,
it's big.
So I posted two threads. First one is the reply to the previous threads. Maybe we can start from there.
Sure.
If you, yeah, that one, reply, click to the replies. Right, that one. So the basic concept in this proposal is basically we have hypervisor layers in XPU and isolate host and XPU or infrastructure side. And I basically had two examples, static VNIC provisioning and dynamic VNIC provisioning. And I think we can start from the static VNIC provisioning case because it's simpler. And in this case, the operator performed the initial setup, which is to provision the VPC, and then provision the VNICs. And once the VNICs are provisioned with the VXLAN, IPsec, or the underlay overlay setup, those provisioned VNICs are present on host, and they look just like a regular SRV VFs. And of course, we have a VXLAN IPsec offloaded, but those offloaded functionalities are hidden from the host. And since the operator already assigned all the VNICs to the host, it is up to the tenant or host to decide how they use it. That situation is basically the same as the regular SRV VFs. So this allows us to basically leverage the existing SRV tool sets available on the Kubernetes. And there are basically two tool sets. One is called device plugin. SRV device plugin is used to allocate the VF and assign to the pod. And the second one is the SRV CNI, which is described in the next thread. So this thread basically talks about how we can use the SRV device plugin to allocate the VFs and assign to the pod. So because all the VFs are already assigned to the host, we can basically use the Kubernetes to simply pick the one and attach to the pod, right? And that's what the device plugin does.
Okay,
So
Dan, I think you have a question that you raised your hand.
Yeah, I'm sorry for coming in with I missed several meetings in the last few weeks. I wanted to just back up and understand the overarching use case. Are you using the SRIOV to provide the primary network of Kubernetes, or is this a secondary network? Sort of the SRIOV is available for the for the containers to use to run some other build some other network. Is it both? Do you draw a distinction there between primary and secondary in this usage?
I'm talking about the primary, but it can be used for the secondary as well. It can be used for the primary because we also enable network policy and the kube-proxy offloading tied to the primary network.
Okay, so then the work here is really to sort of the mechanics of attaching into each pod a VNIC or VF or whatnot, and that's the focus of the work that we're doing here.
Yes and no. So in the previous week, I basically presented overall architecture, which basically has the CNI working on host side and network policy and kube-proxy offloaded to run on XPU side. And this thread only focused on the host side first. And host side basically the SRV CNI currently used for the secondary interface, as you pointed out. And it works for the touching, but SRV today, CNI today doesn't work with the kube-proxy and network policies. But those basically the kube-proxy and network policy will be supported in the separate mechanism, which I can basically talk about next level of the details, but that was presented in last week.
Yeah, so I'm kind of a little bit, I mean, I see where Dan's heading. I'm kind of on the same page. I mean, I've used CNI, SRV CNI before for secondary interfaces, but it doesn't do a whole lot as far as the primary. It's mainly just plumbing in the secondary interfaces.
Okay, and let me go back to, I guess, or if we can present my slide.
Yeah, well, I've got a slide if you want me to present.
Yeah.
And we can talk here for a second.
Sure.
Do I steal it or do you have to let it go? Let me see if I can.
Yeah, maybe we need to go back. We can go back to my slide again.
Well, I've kind of got, give me just a second. Let's see. Oh, I got too many windows open here. Where is it?
You should be able to share now.
Yeah,
That's
my quick feedback is that the SRIOV CNI is probably the wrong place to start. That was my concern, because that's meant for that's meant for secondary networking.
Sure,
So
sure. Okay, so this picture, the SRV CNI is used on host, and that only perform the attaching the interface to the pod VF and nothing else. And this is used for the secondary interface because this mechanism does not support network policy and kube-proxy. For that, we will add a mechanism, which is to basically run a network policy and kube-proxy running inside XPU, and basically set up the stateful firewall and stateful load balancing through the OPI API to the data plane. This is the container network data plane offloaded to the XPU.
Billy, correct me if I'm wrong. What I'm hearing from Toshi is maybe the shim CNI that we were proposing to do is the SRV CNI that Toshi is talking about.
Yeah, it's sort of, yeah, I'm kind of, yeah, so we have talked about the shim, and that could potentially be
SRV.
something like the it will need something similar to what is in the SRV CNI in order to plumb the VFs into the pod. So in
So
that
if we align
scenario,
terminology, maybe this we can call this Toshi proposal of using the SRV is a shim, and then maybe we can talk in the same terms.
yeah, that might.
Well, I think the maybe Billy or Dan, you can talk about why using the SRV CNI is a wrong choice. That probably clarified.
yeah, I would say for primary networking, we should look at what CNIs are used today. And I think that the most common ones are like, Cilium and Calico are using. So I would think that if there were some modifications to the CLI for OPI, the rabbit hole we've been going down with Cilium, with Calico, is to say, all right, well, these are the required changes to your CNI that you would need to be able to enable the two things that you have drawn here is a direct connection from hardware into a pod. That's like number one, and then number two is the offloading of the routing, the load balancing, and the policy into the infrastructure. And so you have those two things that you want to get done, but you need to apply them to CNIs that are used today for primary networking. You can't, doing it for SRIOV doesn't really make a lot of sense because, SRIOV is probably running some networking that isn't even related to Kubernetes. It might be running, some sort of 5G or whatever AI workload, that is that isn't related to your Kubernetes networking. So that's why I at least the work that we've done so far seems to point towards needing to. I like the idea of a shim or some sort of set of requirements, but you have to bring it into the existing CNIs today on the primary side.
Right. The SRV CNI is basically just setting up a wire or pipe into your pod and doing nothing else as far as setting up your networking, that part down below your whole data plane. It's just a pipe.
Which is exactly what we needed for shim, right, Billy?
Right. The setting up the network, I'm basically setting up as part of the initial provisioning. So I'm not actually opposed to use the Calico. I actually don't have a strong opinions between the Calico and SRV CNI. If the Calico works fine, I'm fine. I'm just saying the SRV seems to work, and if it doesn't work, we can go with the Calicos. And you can point where I'm wrong about it, right? So for the network setup, I'm basically saying we can provision to set up from the XPU side. It doesn't have to be set from the host side. And
well, I mean, I think there's a little more dynamic nature to it as far as running a true, like Kubernetes deployment where, pods come and go and you have these things need to be plumbed into your data plane properly so that you can then apply the the service and network policy on top of them. I mean, I agree the CNI doesn't do a ton, but they're still just trying to, the SRV is not quite enough for what you need. It does have that, the part where it's tying the VF into the pod, but it's missing really the kind of plumbing it into your data plane, which I think, if I understood you correctly, you were doing a lot of that statically up front, which I think there's this little more dynamic nature to it.
Right, I agree. The SRV does nothing to for the service and network policy, but we have separate mechanisms. The network policy and the kube-proxy agent running on XPU, monitoring the Kubernetes APIs, and setting up the necessary firewall and load balancing to the data planes that is offloaded to the XPU. That is not controlled from the CNI itself.
And this was, something that it's really, I don't think either is right or wrong or anything like that. It's really a question for that little tenant or the user at the top is, this picture here, it's almost like, I mean, you could take that green box, make those VMs, right? And then instead of using OVN or some other solution for the networking, you're just using Kubernetes APIs. So it's sort of taking our existing sort of SRIOV IaaS VM solution and just reapplying it for Kubernetes. And just the fundamental question is that how Kubernetes sysadmins want to use it as, or because I don't see that as a current usage model today. So for someone to adopt an IPU DPU, they would have to really change the way that they deploy potentially. And so that's always been the fundamental question. So there's nothing wrong with your picture. I'm aligned to it. I'm not saying we must use Calico or Cilium, but I really would want to hear from a user, who is wanting to do this and wanting to offload as how far they're willing to go in terms of changing the way that they deploy.
Right. I think I totally agree with your point, and it basically handling the host as a bare metal system, and this basically, I guess the overall concept is we use the same infrastructure for bare metal as a service or virtual machine or Kubernetes. And basically as I said earlier, the hypervisor layers reside on XPU and the control comes from the XPU or infrastructure or operator side. So that's the basic. But when it comes to the user interface as a tenant, it doesn't change any of the Kubernetes APIs. Still, the user deploy the pod to the master, and API is now monitored from the XPU side because the network policy and the kube-proxy, those controllers now run on the, basically the XPU, but still use the same Kubernetes mechanism to reflect the changes made by the tenant. I think the major change is the initial setup, like a user using the kube atom command or deployment and set up everything from the host side. That's not the case. The initial setup comes from the operator side and provision the VPC or VNix and all the VXLAN setup. Those initial setup is performed by the operator side. But once the Kubernetes is up and running, it is expected tenant perform the same way. When using SRV, there needs to be some mechanism to inject resource request to the SRV device. That may need to be implemented as a webhook to the master node. But for that, maybe next to the level of the details. But
well, I mean, I think we're at that next level of detail. I think it's kind of where we're headed next.
okay.
And so,
So
yeah.
Vipin, you've got your hand raised for a question.
Yeah, I think it's important to describe what use case we are after here, because if I am a service provider and if I were to go ask them, they would say that, yeah, just give me a VF into a pod and I'll use my container network function into that just fine, and I don't need it for primary. But if you go talk to maybe Toshi, your use case is it service provider specific? I didn't think it was, but it was more about deploying Kubernetes as a primary way of deploying pods, and maybe those users are different. So I just wanted to highlight that, if you were to ask different users will give two answers, and a service provider use case will very easily, comfortably say that, yeah, Multus based device plugin or SRIV device plugin is good enough for me. I'm good with it. I really don't need to make everything go through one single primary interface.
Yeah, this is to support primary and
Correct. No, I was just giving context on why SRIV interfaces has been most commonly used as a secondary interface is for the network functions to be implemented in SP environment, which serves its job really well there. And you don't need it to be primary. Sure, you can use it as primary, but they're not dying to get it to be used for the primary interface, so that the performance part of the network function is the one that is going through the SRIV interface and not the management and control part of the pod.
So I agree with you, Vipin, and I think we need to specify in. So, I mean, I'm angling for, the primary interface being.
Yeah. I think I just want to make sure we ask the right users, because otherwise we will get the answer that, okay, what we have as a secondary interface is good enough.
Right. And so, yeah, I mean, personally, I'm taking it from, I expect the default Kubernetes network being offloaded into the DPU. Okay. And then that does bring up where it gets tricky though, is because in a typical Kubernetes deployment, taking the DPU out of the picture, most of the time you have virtual interfaces being used, like vETH pairs, which you can basically just create and delete vETH pairs as you go. I believe a lot of what we're doing with the DPUs is we are exposing a VF or a sub function into the host, which is a limited resource. We don't have a unlimited number of VFs that are being plugged into the host. So we do have the device plugin model in a way to manage these VFs because they are a limited resource. Do you agree with that, or?
It's fading away. I would say that yes, it is limited resource depending on the generation of the card you use. I won't go to vendors specifically, but everyone has the gradation of the cards that they have released in the past and now and moving forward. I believe you can always say that, well, I want 20,000 containers on a node, or thousands and tens of thousands of containers on a node, especially if you go super lightweight containers. Then yes. You will run into a limitation, but that limit is itself on the devices is definitely going up into high hundreds of thousands at least. So
but do we need to model that now, or are we just going to assume that if we run out of? I mean, that's a part of the question. And do we need to have some type of device plugin model where, because like right now there are devices on DPUs that have a limited number,
I think the limitation comes with the SRIV technologies, and industry is heading to the scalable IO technologies, SIOV.
I agree, but we're not there yet. We're headed that way, and there are. I mean, I'll just I believe the NVIDIA BlueField 2 has a limited number. Maybe the BlueField 3 still has that number. They're moving to sub functions, but they're not there. So are we modeling this for that now, or saying, well, we don't care about that because in the future they're going to be bigger, so we don't need to take that into account?
This approach is more like designing for the tomorrow. I totally agree that today this may be limited, and number of the pods you can deploy will be limited. But since that restriction will be addressed in a couple of years or maybe next years, or I don't know. So, but I totally agree. The number of the VFs are rather limited today, yes.
Yeah, I think that's the secondary consideration, Billy. I think the main thing is that if we were to go that I think Dan was highlighting is if we were to go with the approach of taking the primary interface with VF, or for that matter, some shim that could associate these primary interfaces to that. I mean, there are challenges that we'll run into, but do we want to use the brownfield CNIs to do that, or do we want to reconsider this as a thing? Because if you are using brownfield CNIs, then yes, all you need is a shim and then throw the actual CNI in the DPU to be able to glue it and then have them program the data path. I'm using very high level fluffy words here, but when I say glue it, it's a VETH pair. This is a hardware VETH pair that is the other end of that is sitting into the DPU data path and not really in the Linux kernel. And the DPU data path is controlled by the CNI running on the DPU. So, so in that sense, do we want that with what level of brownfield use cases and CNIs, and if so, which ones?
Dan, you've got your hand raised.
On mute. Yeah, I was just saying that I was going to ask the question. This looks really similar to the setup that NVIDIA has been presenting. It's almost identical. It's just you take that OPI API blue block in the bottom corner and you replace it with OVS OVN. And they have already done the work to take a Kubernetes policy and endpoint discovery from the proxy and program that into OVN. All of those things are already supported. And then you treat your pods like VMs and you're off and running. Is this influenced in any way from that work? Is it related, or is it the next gen, or not really looking at that solution that they're working on?
I'm personally not aware of the NVIDIA's work.
Okay, I see. Yeah, it's extremely similar.
Okay.
I'll reach out and or maybe I'll just post a link to it in the chat later.
Thank you. I'm aware of the NVIDIA's like ASAP2 or Snap or those technologies, but not aware of the CNI offload.
So, I personally have worked with NVIDIA on that. So this is the HP proposal that I just made a copy of so I could talk through some points, but I am familiar with it and I am kind of leaning on in that direction. So just so we're on the same page.
So you did all the work, Billy. What's left?
No, I didn't do all the work. I watched other people do the work.
So I think key point here is the just like I described in the those box. I'm actually don't have a strong opinion about SRV or Calico for the CNI. Basically we have a CNI running on the host and doing the attachment for the VNIC to the pod. So, and I'm just making the SRV as an example to leverage the existing one. And if we can leverage the Calico, that's fine. So,
but can we abstract it, Billy and Toshi? Can we just call it shim CNI, and it could be based initially on SRV and evolve to something else, but we just can table it for a second and this is shim, which we define APIs and how it works with all the rest of the system.
Yeah, I'd like to know, like from Dan, like what his, I'll kind of where you're headed with this is based off, or it's kind of NVIDIA like. So, and what part do you not like, or do you like that it's like NVIDIA that so we're on the same page?
Yeah, I put my my three, maybe there's probably many more. The three common approaches that I've seen.
Yeah.
And the first one is, secondary network, you get a VF. It's not related to Kubernetes. You can do offloads like crazy, but it's in a different context. Like IPsec offloads or RAN or whatever. The second one is what NVIDIA has proposed with OVN, which is, so you ask what part do I like about that? I like that it's OVN, so it's completely standard. So you're mapping between two standards. You're mapping from those red network policy and kube proxy boxes into OVN, which is a known entity. And at that point, there's not really necessarily a need to invent a new set of APIs around that, because you're going from standard to standard. I like that part about it. What I don't like about that approach is that it does require the user. We call it model. We have like a model 1, 2, 3, and 4.
Yep.
We call it model number 2, where you have to require the user to deploy their system really differently. The model 1, the one that we've been working on with Calico, is the third option that I've seen, is where you're saying, all right, well, I know that my user may not necessarily want to change a lot of things, but what they do want to do is go faster and use networking offload, Kubernetes networking offloads. So I think if we can maybe just sort of define, maybe it's a fourth model that we're proposing here, but if we can just compare this to those existing models, and then I think we need to defend a little bit, if we are saying, oh, we need a fourth model for OPI. Why is that? Like, why do we need that bottom right OPI API block when it's already been demonstrated by at least one vendor that you could just use OVS and OVN for that? So that's where I'm getting at.
All DPU vendors can do OVS OVN then?
We can. I can't speak for others.
If we cannot do it across the existing vendors that participate in OPI, we cannot really this is my concern. Maybe they can, maybe they can.
I mean, I thought that we said that a while back in the use case group that OVN was going to be an early OPI use case. Did we throw that out? Or it just didn't get traction compared to the other use cases?
Not sure it got traction.
And I don't, and what does that mean? Does that mean that we're running OVN on the DPU?
Yeah, that's right. Well, I mean, OVN runs, it's sort of distributed across, but you're certainly running OVS on the IPU DPU. So, and then it becomes a question of, you're going to run the pieces, the sort of the agent OVN talks to OVS, and then the SDN controller effectively runs outside of the box. So that is that's a really common way to do the VM type of approach. You don't have to use OpenStack, but it works with OpenStack out of the box, and it's also a common way that if you want to do infrastructure as a service networking, you just want to give people VMs or bare metal hosts or whatever, you can use OVN. So I just want to, I guess maybe it's an AR to say, hey, maybe we need to go back to the use case group and just ask them for their disposition of OVN. Is it just like, oh, we're going to get to it? Or if we discussed it and we said not everyone supports it, so we threw it out, like that would be really interesting to know. But I think that with a proposal like this, where it is very OVN, is very similar to OVN, that we'd have to be able to defend doing something that is like the same but different.
Okay, Prasad, you've been very patient. You've got your hand raised.
Thanks. So I didn't join last couple of sessions, but I was going over some of the Slack exchanges. One question I have is on the two red blocks that are shown in the DPU. Do they represent unmodified Kubernetes pods that would run normally on x86 without the DPU? Is that what it represents, or is that
It represents as a controller. How this controller runs is probably up to the vendor to decide. This can be a container, and vendor may provide OCI runtime to run those controllers, or vendor may decide to run the Kubernetes, or they can be a regular Linux processes managed by the system lead. I think that part is the implementation details. What this proposal is proposing is that we need two controllers and monitoring the Kubernetes APIs and call the OPI API. And this OPI API is to be defined. I'm intentionally left API definition for the separate discussion. If this is the OVN, that's fine. If the OPI adopted as a common APIs, so that's also the separate discussion. But what I'm saying is that we need some industry standard API to be defined in this blue box.
To give a context to it, Prasad, I think we have two discussions here. One that was brought by Billy, and Billy, you can comment on this, basically bringing the existing CNI into the DPUs and run it inside almost unchanged with a shim CNI running inside the host, if I understand correctly, Billy.
Yeah, that was scenario one. Yes.
Scenario one.
Yeah.
And Toshi is saying that we doing network policy and kubeproxy inside the DPUs. And Toshi, I'm still not sure myself whether those are unchanged from existing CNI providers, or you propose for us to implement the network proxy and the kubeproxy ourselves.
Oh, okay, sorry. The network policy, I'm basically considering the Calico Felix is a good example, and we need to modify the Calico Felix backend and come up with the OPI backend driver. kubeproxy, this is actually rather simple program, and we could either start from the existing kubeproxy, or we can write a new controller to basically perform the kubeproxy functionalities with the OPI API as a backend.
So at least from the way I took it, and Toshi, please correct me if I'm wrong, but you know, in my drawings that I presented like 3 or 4 meetings ago with the scenarios, we just had a box, and it was kind of like for managing the network infrastructure, and we called it, you know, a CNI. But a lot, and I think in text, Toshi said this, is that some CNIs take the functionality of the network policy and the kubeproxy and fold it into the CNI. For example, Calico does that, OVN Kubernetes does that. A lot of the bigger ones, you don't actually run kubeproxy. It's actually that is kind of absorbed into the CNI. So it's kind of a block, a bigger block, even though functionally you have a CNI, which is what kubelet calls with your add command, delete command, you know, add pod, delete pod. Whereas, and then they have a daemon set running that handles the kubeproxy network policy functionality. So at least in my stuff, I had, you know, those two boxes were drawn as one box, and I was calling it the CNI. So I think
this will be provided really by
the CNI, whoever.
Okay, so I'm sorry, in case of the Calico, the Calico CNI comes with the multiple components inside. So they have a CNI portion and network policy portion as a Felix I mentioned.
Right.
Those two are actually two separate modules. But when you install the Calico, both get installed. And Calico also allow you to use the existing kubeproxy, or Calico allow you to replace the kubeproxy with the one from the Calico.
Right.
And
right.
so there is some, you know, flexibility. And but the point is basically put in the box as a functionalities. Whether you actually use the one container to handle the both, it's also the implementation. But But we do need basically the two functionalities, network policy and kube proxies, offloaded to run in the XPU side.
Dan,
The-
you got your hand up?
Yeah, and when we did with Calico, instead of moving network policy, the Kubernetes policy API or the kube proxy off of the host, we just left them there. And then you had that same gray ACL comma load balancer API there that connects into an OPI API. So that's a really good example of a place where OPI APIs are really valuable, where you're creating a set of APIs that the Calico or Cilium CNI or wrapping around the Kubernetes APIs, could adopt, send these messages to the infrastructure, and then the IPU, DPU, or software or magic, could be a switch even, on the other side of the infrastructure would take those ACL and load balancer commands and apply them, to using whatever mechanism they prefer, that left arrow that you have. So that's how we worked on it with Calico today. I think we call that model 1, where that doesn't change the tenant's deployment model. But it does require you to go to, every single vendor that is interesting in your that wants to add this offload and convince them that the OPI API into the infrastructure has value.
Right. And in my the presentations that I gave, I know on the brownfield scenario 1, I suggested moving the CNI down, but on the scenario 2, where we were talking about, more of a greenfield and taking advantage of OPI API, I said that we can run it either on the host or on the DPU. And so I think if I'm not mistaken, that is what you're saying. For Calico, you had it up, but you could potentially run it down as long as you're just calling those APIs to do the function for you.
Yeah. And I think that, the model 1, the model 2, those make sense. But I kind of think that what will happen is that we had this model 3 where it's some weird combination of the two. But then hopefully the OPI APIs are the same. But I think I am not entirely following how model 2 will work. I think we'd have to. I mean, this is essentially model 2 that's drawn here, and the questions I'm having is that in that double click, exactly what are we?
Now, when you say model 2, this is in your picture with your 4.
Yeah, the ones that we had before. Yeah.
Okay.
It's in that case, what's the
Then-
CNI? In that case,
But Dan and Billy, I don't see relevance of this, because who cares, like from API perspective, who cares the network policy running inside the DPU or outside of DPU? We need to define the ACLs and load balancer APIs towards the OPI API. If
I agree.
OVN is a good proposal that can be adopted by all the vendors that participate in an OPI, we just vote it and agree on it and move forward with that. If we cannot do that, we need to propose a new set of APIs that can be accepted by everybody else. I don't really care where network policy and kube proxy live, or whether they are two separate blocks or one big block, right? We need to move forward with actual, doesn't really matter where you run things. What is the API that we're abstracting? So all the vendors can actually do the offload themselves.
yeah, and I have questions around in this model. What is the CNI? How does it work? If we're just saying, oh, it's an SRIOV CNI, it basically does nothing, then.
So we talked a little bit about that in previous meetings. You can watch the recordings and look the presentation, but Billy presented that there is kind of new CNI shim that have to run on the host itself, that shim doesn't exist today. And one of the proposals is maybe, I don't know, Billy, correct me if I'm wrong, that OPI will implement this shim CNI as an open source teaching layer, right?
Yeah,
Go ahead.
It was an OPI shim though, wasn't it?
Yeah, so we didn't dig into details. So, and I was taking it from, the limit from a device plugin model in the fact that you have a limited number of resources. So something in the CNI gets told, I'm using VF3. So now you need to let the DPU know, that this pod is associated with VF3 so they can plumb it in correctly. So the shim, in my mind, whether I honestly didn't think it was a full CNI shim, it would probably be a library that an existing CNI would leverage that could create a OPI type CRD to transfer information between the host and the DPU, so that you would have here. Oh, sorry, I'm on the wrong window here.
You can pull your slides if you want.
Well, I kind of updated. There's a reason I made a copy so I could update it. So if we decide that we're not going to do we don't have to worry about limited number of resources, and we don't care that everything is virtual. We have an unlimited number of VS, which I don't quite buy quite yet. I know long term we probably have that, but your device plugin gives you manages your limited set of resources. So he's the one that makes the decision on which VF is being used. And so I was
how the
thinking
communication between that and DPU happens, because you
so,
said there should be coordination. So there is an arrow that is not showing here to DPU.
So right here, what I've got is I just added the CNI gets told he's using a particular VF. So now the OPI we create an OPI CRD, which is basically an object within Kubernetes that says, pod XYZ is using VF3. And then the CNI port, you have a shim layer or library that's creating the OPI CRD that can then something running on the DPU can then call the APIs and set up your underlying network.
I'm not sure if we need additional CNI stuff on XPU. But
not an additional, but some servers need to be here to monitor the CRDs, right? And actually translate that into the actual APIs, for example, for OPI API.
Yeah, so once the VNIC is attached to the pod, Kubernetes has the object called endpoint, and that endpoint is reflected to the network policy and the kubeproxy. So the kubeproxy and network policy can manage this VNIC as endpoint object.
But does that have enough information for what you need?
Yes, that's how network policy and the kubeproxy works today. So they manage best pair as endpoint, and if the best pair is the virtual network interface, where VNIC doesn't matter because Kubernetes manages it as the endpoint object.
Okay, I'm going to have to dig more into that and make sure. I don't think it has enough information, but if you say it is, and then you could then we don't have to create that additional CRD.
Right.
But I don't think it
object
does.
has the IP address associated with it, and that's all basically the kubeproxy and network policy needs to know about.
No, but the data plane needs to know which VF is associated with that IP address.
Yeah,
the IP address is already this case is the static provisioning.
Okay, I'm not doing static right now. We're not doing static. I thought we'd kind of step past static.
Okay, so that's a different discussion. But whether it is a dynamic or not, okay, so this is a static case, and the operator already assigned IP address to the VNIC. And yes, the prerequisite is the VNIC IP address is pre-assigned, and whether static or dynamic. And since the VNIC interface is associated with IP address, and the Kubernetes endpoint has IP address, so you can tie the Kubernetes endpoint object to the VNIC inside the XPU.
Prasad, you've got your hand up.
Okay, so one question I don't know anyone else is not asking. Maybe it's not evident to me. So why do we have independent connections from the host and the DPU to the K8s master? I was thinking the networking is all going through the DPU anyways. Wouldn't the host go through the DPU even for whatever communication there are?
For management
that-
even, Prasad?
Yeah, I mean, otherwise you have two entities on the same cluster now, right? That's what
What-
this.
What if you cannot trust the host? How host can control the DPU?
What if you cannot? So you cannot trust as in who's you here?
Trust, the host is untrusted.
Okay, so
Yeah.
okay, what does this represent? Does this represent there's one more NIC card on the host through which the host is able to talk to the K8s master? What does this mean?
So it means the XPU has out-of-band management interface, whether it is a separate uplink or sharing the uplink with the management and the host data link is the up to the implementation, but it has the out-of-band management interface. And that's what basically used for connecting to the master.
Okay, so I understand the DPU has it. The host also has something separate. That's how it looks like? The host has one, the
Right,
DPU
the
has.
host has the overlay network, has accessibility to the master node. Yes, that
is
is
that-
going through the underlay. So that one, so okay, from the master to kubelet, physically that access is encapsulated with the VXLAN headers and going out to the uplink in the picture below.
That makes sense to me what you said, but then that overlay for me is handled by the DPU in the first place. So it should go
Right.
through.
And the master maybe, I'm sorry, the master may be in the same VPC or maybe in a separate VPC. If it's a separate VPC, it requires VNI routing. But when you think about Amazon EKS, the master is managed by AWS, and AWS has their own VPC, but you do have a connectivity between your EC2 instance to the Kubernetes master, and the master, and you basically access through your EC2 instance ENI interface, right? So,
you are assuming more interface, NIC interface is available on the host, separate from what the DPU is able to connect to, right? So the DPU is
Um,
You're asking, I understand now, Prasad. You're asking basically how the connectivity from the host to Kubernetes master happens, whether there is a separate NIC for that, or you use the DPU to do so. And if you use DPU and DPU is unprovisioned yet, how you do that first connectivity from the host to the Kubernetes master.
Yeah, exactly. So I mean, this arrangement by design looks like it says the host somehow can talk completely independently to the master. Right?
Okay, so this picture kind of omitted, but there's a separate VNIC attached to the host.
Yeah, that's
and
what.
that is also on overlay network. And the kubelet is basically using that VNIC as the VNIC assigned to the host bare metal system. The
Okay,
kubelet as the basically the process running on a host using the VNIC interface attached to the host directly.
Okay, so I'm not sure that is always the case. I think there are two situations. One where it's the DPU that's also offering that VNIC for the host to do that communication. I think that case exists.
Yeah, I think it's a common, because also this DPU have a lot of it's 200 gig or it's big things, and most of the users are asking for one DPU. It could work with multiple like another VNIC, but I don't think that the design is forcing to have an additional NIC, because if the DPU is on the infrastructure already provisioned, it can provide also the connectivity of the node. So I don't think it's mandatory to have a second NIC on the host.
Good. So the reason I was leaning towards that is because then you do get one opportunity to the problem that was being discussed earlier in terms of how you do the plumbing, right? If traffic is going through the DPU, you have an opportunity to intercept it. it's going through the DPU, it's going through you. You are the one sending it out. So that K8s API is going through the DPU. It's not, you don't need these other arrows. Right? You don't need to go after again.
Sure. Okay, so I didn't describe the detail about initial setup, but initial setup, it basically assumes the DPU has, say, 32 VNICs, and one VNIC is assigned to the host directory, not to the pods. And that VNIC may have a separate IP address, and because we want to separate host IP address from the pod IP address, but it can be pre-provisioned and basically for the host to use. And it could be also in the overlay network because we want to protect the host from the underlay as well. So that VNIC is basically the host kernel to use, and from the host network namespace. And the kubelet is running on the host network namespace. So it basically access to the VNIC attached to the host. And it could be attached to the same, basically the XPU, and it goes to the same data plane and do the VXLAN and basically access to the master node.
Yep, no, I understand. I'm just saying there is one more case that you don't have the VNIC. So then the diagram changes quite dramatically and the options change as well.
Right.
So
I think it is the design doesn't require the secondary NIC, but you may choose to have the secondary NIC too. So.
Okay, good discussion today. Hopefully we can keep the thread going in the K8s project area so that we don't continue, we don't lose time on this. If anybody has ideas for additional architectures, please go ahead and contribute those even out onto the Slack channel. We'll pull those over and try to keep track of them in our GitHub site and keep posting to that location also.
But Mark, I think that the feedback is still, it's not that we're proposing alternatives, is that we're just asking questions about what is the actual end user use case? How is this being used?
Correct. We need to find that out. We also need to continue to drive to what we think that this implementation will be also, so that we can then start to drive out the API definition. So those are the two things that we have to address.
And
all right.
Dan, can I look at the model 1, 2, 3 you mentioned? If you can share.
Yeah, I'll post it on the Slack.
Okay, great. Thank you.
Great. All right. Thanks, everyone. We'll meet up again next week.
Thanks.
Thanks.